We have three talks this session. They're all on user experience. The first one by Jen Kotler will be remote. And the topic is empowering science with good design. Take it away, Jen.
Hi, everyone. Really excited to chat with you today about empowering your science with good design. Who am I? I'm Jen Kotler. I work at the Space Telescope Science Institute, and I'm here in Baltimore. I'm sorry I couldn't be with you in Malta. I just had a baby 3 months ago, so I decided not to travel with an infant. But nonetheless, I'm excited to chat. Specifically, I work at the Mikulski Archive for Space Telescopes, generally referred to as MAST. We hold data from a whole bunch of different space telescope missions, pretty famously the Hubble Space Telescope, and also now the James Webb Space Telescope. In the future, we'll have Roman, and we have a bunch of other missions as well. Our data is all free and available to anyone. Uh, Check it out if you haven't. It's very exciting. And our mission, which is really relevant to the design decisions we make, is to maximize the scientific accessibility and productivity of astronomical data. So that boils down to two key concepts, which is to make our data accessible and make it scientifically productive. Those two things, you might make different design decisions if you only want your data to be accessible or you only want it to be the most scientifically productive. You might make different design choices. So they're sometimes in tension with each other, and they're things that we think about when we're building our software. So my goal as a designer is to create archive tools where astronomers with different levels of skills can all come to our software and find data that they need for their research. And I also want to enable astronomers to find data that they didn't know that they wanted. I want people to have nice moments where they learn things and are able to go in new directions because that's how science works. So let's talk about accessibility and what it means in this design context. When designing science tools, I always think about accessibility. I think it's really important, and it's not necessarily just with people's disabilities or abilities. There's other things to consider as well, like their level of education. We want our tools to be accessible to grad students and astronomers who've been working in the field for 40 years. We also want people with different levels of English language comprehension to be able to use our tools. Not everyone is a native English speaker, but we don't translate our tools. So how easy is it for people to come to our tools and understand the word choices? What kind of language are we using? Also, people have different levels of technical resources, internet speeds. Not everyone is on the newest laptop. Do our tools work, even if you're on a 7-year-old's computer with not much processing power? And so a note on disability specifically, because this influences design choices a lot if you care about such a thing. We often think about disability as a medicalized thing that's inherent to a person, but since we're in the design context, I really want to shift all of your perspectives. I really encourage you to look up the social model of disability, and then you realize that this is something that impacts all of us with design. And I'll give you some examples. But in the social model, you're disabled based on your experience with the built environment. So when we're designing an environment, does it enable or disable the people within it? So here's an obvious example. A person using a wheelchair is fine moving through a building. They're not experiencing any disability until they encounter stairs, and then they're not able to get to the second floor. So in this context, we think about the lack of the option for them to get to the second floor as the disabling experience, but not the fact that they're in a wheelchair. So what would happen if the only way to get to the second floor of a building, you had to climb up a rope through a hole in the ceiling? I think a lot of us would be disabled by that design choice. So it would be obviously the rope, the choice of a rope. Only the very most athletic of us would be able to get to the second floor. So an example within our current context, talking about science tools, a sighted person comes to our tools to analyze data. and they use visualization, so they're analyzing visually. Perhaps a blind person could come to our tool and analyze data using their ears orally, leveraging sonifications instead of visualizations. Neither person is disabled in the scenario, they're both able to do their work. So, as we design software, we need to be thoughtful that we're not building in disabling experiences. And that could be on any of the axes I spoke about earlier. Let's talk about design process. Here's the process that I use when I'm going to design our science tools. So before I came to Mast, there hadn't been any designers working there previously. We had a lot of tools that had been built, 10, 15 years earlier. So this is what they looked like before, and still some of these are active, like that's the portal in the upper left and still actively used. So my process is an iterative, user-centered cycle. So it's cyclical. We do the same thing over and over again, but it starts when you're kind of defining what you want to learn, defining your questions, I'm calling it. Then you get you design something, you get feedback to answer your questions. You design something again based on that, and then you build it, and then now you want to look at what you've built and get feedback, and you go back to defining your new questions and getting feedback. So to break that down into more concrete steps, step one, I'm usually given a project, and it's often on a topic that I don't know anything about because I'm not a PhD astronomer. Some examples of projects I've worked on are a website to search and download telescope data. That's, you're right, our core thing we do at MAST. Sometimes I focus on data visualization tools or sonification software. So these are more tertiary things that we do. Well, data visualization is pretty core, actually. Okay, so that's step one. The next step is that often I have some moments of being a bit overwhelmed because I don't know anything about this topic. How am I going to design something? And I put this in to mention that it is totally normal uh, to know you have to do something and not know how to do it. And that means you're doing a challenging thing. Good job. And don't worry, you'll be able to figure it out. The next step is that you talk to people. This is how you figure it out. The people that I talk to are our users, which are generally scientists. I also speak a lot to developers to figure out what is actually what we're capable of building technology-wise. And I have a few different ways that I go about gathering this feedback, which I'll go into detail later. But often I'll meet individually with people, or I'll run larger brainstorming sessions within a larger group of stakeholders. And the key thing is just to ask questions. Like getting good at asking questions is, in my opinion, the most important part of design. And I recommend this book on the right. It's called Innovating for People. It's put out by the Luma Institute. And they have a lot of, they give you a lot of specific methods that you can use to run these design workshops and get feedback. And it's very helpful. Step three. So after I've gotten these ideas and I've asked a lot of questions, I start drawing to make a mock-up of what we want to do. And the mock-up, I'm going to repeat, is just a drawing. We don't want to put much development effort in at this point because development is expensive, drawing is cheap. So I'll make mock-ups. I personally use Axure. You could use any program you want. You could even draw it out on a piece of paper if that's the skill you have. So I both make layouts, but I also will do workflow diagrams. So on the right-hand side, you could see there's a workflow diagram, and some of them are more or less complicated than the others. And then I'll also write notes on behavior within. So on the left-hand side, I have a mock-up, and I have little details I've written to explain why certain things look the way they do and how it will behave. Then the next step, step four, is I get feedback on the designs. And so this is still before we've built anything. I go and usually talk to people who might potentially use the tool, like, or someone with a good background knowledge on the topic. I ask them what's confusing, what's missing. And when I'm talking to people, and this is in general when you're gathering feedback, you need to be really careful with your language. You don't want to make any leading statements. You don't want to get defensive if someone gives you feedback you don't like that maybe is offensive to the design you've come up with. Because the truth is, It is not about your ego, it's about making a good product, and you need to be able to take feedback, and you want people to be honest with you. So if you're defensive, they won't be honest with you, and you'll make a bad product. Uh, while you're doing this, you should be not be the one who's talking the most. You should be listening because your goal is to learn, and take lots of notes so you can actually act on the feedback you've gotten. So a method that I use personally is I take notes right on top of my mock-ups. You can see the little pink sticky notes on this, and that helps me keep track of the comments within the context of the design. So that's a really helpful thing I've developed. And then step 5 is iterate and repeat until you're ready to do development. But oh, by the way, not all the feedback that you're getting makes it. So I want to be clear that I incorporate a lot of feedback, but I make sure that the design remains simple and easy to use. If you incorporate every single piece of feedback that someone gives you, you're going to end up creating a really complex tool. So know that as you're hearing feedback, you're listening, you're writing it down, but you do not have to take these ideas. You're the high level designer. It's your job to decide where you want to keep things clear and where you want what's relevant and what isn't. Next step is I work with developments during implementation. Um, Often I'll give feedback on visual design after it's built. Sometimes things don't look exactly as they looked in the mockups, and that's okay. Sometimes we iterate within the development process. And then after we have a a functioning tool, I'll often do a round of usability research, which I like to think of as the science of design, because it's the most, design is a bit of a, what, I don't know if I really want to use the term hard skill, soft skill, but you're getting very specific feedback and you're able to act on it. So some companies, like you could work in a place that have real specialists in user research. They might have eye tracking software. Their entire job might be getting user feedback. I do a bit of everything, so I don't go so in depth, but I'll do things like usability tests. I'll look at analytics of our websites. I'll do one-on-one interviews. We'll do surveys for larger groups. And then that feedback we get, we use to inform improvements to whatever piece of software we just built. And then we might go through another round before we publish anything for the first time. So yes, that's step 8, integrating the feedback that you've received back into the design. And then eventually you'll publish the tool hopefully, to your audience, but then you might want to continue building on it. And so then you would use the same steps that I just said. Let's say you want a new feature, you'd start by asking questions to people, figuring out what you want the feature to look like, making a mock-up, etc. Okay, so let's go into more detail about usability research. There's really a ton of this is a very deep topic. I'll skate across the top, but you could learn a lot and do a lot with this. And I think talking to the community and getting feedback is really important because we want our designs to be user-centered. So we need to talk to users. So the first thing, the most common thing I do is usability tests. So the way that works is I have a script that I'm following, and they have tasks, and I'm asking, I'll meet with a certain number of users. Sometimes it's 5, sometimes it's 10. You don't really need to meet with a huge number of users. I think any more than 10 is pretty much unnecessary because the thing is, if one person's not able to complete a task, you're not really sure if it's the design or if it was them. Once 3 people can't complete a task and they're failing in the same way, you could be pretty sure that your design will go back to your drawing boards, to the drawing board and try to work on that. Then I've also come up with some ways of doing asynchronous feedback. I mean, a common way is just doing a survey, right? But a cute thing that I've been doing recently is printing out images of our software, posting it up at a conference, and people can leave sticky notes. And it's not a way of getting a ton of deep feedback, but you can get a sense of things. Like there's a sticky note in the upper right where they're asking the ability to save for like user preferences to save columns, and then someone wrote +1 on it. So we know multiple people who pass by the poster want that. Someone just wrote happy, which that's nice to see. and also running design workshops. So um, oftentimes when you're trying to brainstorm, it's really important to give statement starters because there's nothing more intimidating than a blank page, right? It can be hard to come up with ideas in a vacuum. So what I've found, and this is actually from that Luma book I recommended, it's really helpful to have short bursts, like maybe 4 minutes on a prompt on a very specific concept, and then you take the next 4 minutes and edit the concept a bit. So here's some examples, and notice that they're really specific. They focus in, and then these are from three different brainstorming sessions I did, but in each session, I would take a very similar question, but edit it and focus on a different part of the problem. So, for example, how might the flow of science data between masks and the platform feel seamless for users? What are unexplored touch points between searching catalogs and data? So you see searching was in all caps. I was changing the word. Um, it's for each prompt. And then the final one is what features are required so that the Sky Viewer is not a waste of space on the results page. So these little prompts to help people come up with ideas. Once you have ideas, and that might be from within a brainstorming session, or let's say you just have a list of features you want to make, a really core helpful thing that I've done, I've leveraged often is the importance difficulty matrix. And so that way you can kind of visually see what ideas are scientifically important versus how difficult they are to actually develop. And that allows you to kind of do a quick cut of like, okay, so clearly these are very important and easy. We might want to start with those ideas, or these other ideas are difficult and they don't seem that scientifically important. So we might never build them. They'll just add clutter. They're not important. Helps build consensus. So I want to show you some things that I've actively worked on and show some design patterns that went into them. So this is our newish, it's a couple years old now, our mission search forms, and they're very responsive. They're following some visual design to make it more clear. We have built-in documentation. In this case, someone's going through a search, they're removing columns, they're choosing telescopes, etc. And then they've searched, they're on the results page, and they're selecting a few observations that they want to download. And so this is a really interesting challenge because we have this one is specific to Hubble, but we want the similar design to work for our other missions as well. So let's talk through some of the design patterns that were just incorporated into that. These are important concepts that I try to think about as I'm designing and laying out what a new product will look like that will be within the mass ecosystem. So the first thing is to leverage shared experience. This is incredibly important. You want to grow a common design language between the different tools that maybe you're producing, but also that other people use, right? If there's a general familiarity with how something works, even if it's not within astronomy, but especially if it's within astronomy tools, you want to follow it. You don't want to reinvent the wheel for no reason. So, to that end, whenever possible, reuse components, workflows. Uh, Within your brand, you want to reuse styling, color, font, icon, and verbal language as well, like written language. You want the same terms to mean the same thing throughout different tools, which is surprisingly difficult. So here's an example. We have two search forms that look very similar right next to each other, but they're actually for different missions. So these components behave very similarly, but they are specific to the different contexts that it's within. So we have this exact same component, which helps with both development and design. We use it across a lot of different missions. This is the ability to search by object. Then we could see how instrument, it's a little different depending on if we're in JWST or Hubble, but they behave in the same way. Same thing with data type. Okay, so the next concept, the next pattern I follow is explaining yourself. So our goal here is to have tools be self-documenting. We want the tool to teach users how to use them. We do that by building in contextual instruction and having documentation within the interface. And just to be clear, we know that people generally won't go and read a book that you've written about that you've documented how an interface works. They'll just jump in and try to figure it out themselves and get frustrated. So you want to give information on how to use different components within that component. And the way you can do this is have by clearly labeling things, having descriptions and definitions in context nearby the area that it's being used. Um, and you don't always have to have them shown. You can have them shown in the moment through like a hover tooltip, for example. And then if something might require a more complex documentation, you can give a direct link to that spot in a more robust documentation. But you don't just link them to the general documentation and expect the user to have to search through and find the point. Bring them to the moment that they need. So here's an example of built up documentation. So we have this component, it's called program type. So the title is helpful too. Hopefully it's a clear title. And then we have a short description right above it that might help explain further. And then we have a hover tooltip that explains how to use it. And within that tooltip, we have a link that brings you to exactly the list of definitions in the more robust documentation. Another method that we use is having labels next to things like acronyms, which not everyone might know. And then we could use visual design to emphasize the acronym and de-emphasize the definition. So it's easy for someone to just visually scan without getting overwhelmed by all the words. Also, it's important to have a very responsive system that invites exploration, allows users to find things they didn't know. So, for instance, um, we have immediate feedback if the target that someone has entered into our form uh, has resolved or not, right? We have this clear icon showing it. We have color, and then we even have text telling how many results there are. So people won't just be failing over and over. They'll be able to catch themselves before they fail expensively. And finally, accessibility. This is through a lot of axes. One is readability. I mean, everyone, please just follow the best practices for color, contrast, font size. They're well established. Uh, Also, things like screen reader compatibility. That's also well established methods to do that. We do a first cut using the web tool Wave. Then we also do usability testing with people who use assistive technology. Use plain language so things are understandable and use as few words as possible. We want to simplify those words. The more words, the wordier something is, the more challenging it'll be to understand. And also, I'm very excited about the idea of potentially using sonification to integrate into our previews so you can listen to previews, not just look at them. In my last couple minutes, I want to talk about some projects that I would love you to know about. One is Astronify. It's our sonification tool. So if you want to want to try sonifying some of your own data, listening to it, see what that does. It works on light curves and spectra. Another is Notebooks for All. Fortunately, Jupyter Notebooks, which are really core to our what we do in astronomy, don't really work with screen readers. So this is a project that I worked on to try to help with that. And specifically, NB Convert-Ally is an experimental notebook export library by Tony Fast. I have the link here. If you want to try exporting some of your notebooks in this, it works a lot better with screen readers. So finally, I want to end on being an advocate because uh, I'm talking to you, your engineers, your designers, your scientists, your people who build things. So please consider this. We live in a built society. We're continually creating that society and we're building new infrastructure. And in this case, we're talking about digital, and that's important too. Everyone knows how important digital infrastructure is, right? And as we're building it, we're making decisions that either include people or they create barriers for them. And that should be on your mind as you go about your work. So please, as you're designing things, as you're building things, ask yourself, does this design decision how does it impact other people? Is it enabling them to do something they couldn't do before, or is it creating a barrier? Thank you, and I'm very happy to take questions.
Thanks, Jen. Are there any questions upstairs?
Yes.
Hi, Jen. This is Vandana Desai from IPAC at Caltech, and I think we've talked before about some of these. My question is about the design workshops, and some of the questions that you listed as that you've tackled at those workshops imply some prior knowledge of, for example, what is the platform? Have you, like, who do you typically get to participate in these design workshops, and what do you think is the ideal demographics versus those who will actually spend the time and give you their input?
Yeah, you're right. That's a really good thing you just pointed out. So it varies by workshop. So that question, for instance, with the platform, it was people who were internal to Mass. They were currently working on that project, and they had a lot of context for it. But we were trying to encourage more idea generation within the team. But then there's been other times where I try to invite external scientists, and we don't have any people who are have that context. So it sort of depends. You could do it both ways. You can either gather people from the outside who don't know anything about what you're trying to build, but might have the scientific background that you're trying to get, or you can use it to generate ideas within your team.
Hi, Jen. This is Josh from Mast. I had a question of when you're transitioning users from maybe a service they're familiar with to a new design, what do you think is the most valuable tool you can give them to sort of get that familiarity with the new product? Is it the design up front? Is it, workshops? Is it tutorial videos? Like, what has been the most effective tool or strategy you found?
Yeah, that's a funny one, and it's one that we've dealt with before. For instance, when we got rid of the older Hubble search form, we first had a link directing people to the new one, so they didn't have to use it right away. But the truth is, I think most people will stick with what they're comfortable with and not choose to use a new thing until they're forced to. So eventually, it did get turned off, and we had to, people moved over, and we were really worried about what that transition would look like. Um, we had really robust documentation within, and I think that is the main thing that helped. I'm not sure. I don't think we ran any like feedback sessions or like question asking sessions and stuff. We just really had we had GIFs showing exactly how to use things. We had a side by side comparison of the older version and the newer version. Uh, there's a lot you could do with that, but it might depend on the thing you're trying to build or in the thing you're replacing.